Hello students, this is Dr. Anita Raj, your chemistry mentor, welcoming you for an important session in P block elements. In this session, I shall explain you the periodic trains of physical properties of group 15 elements in detail, from which you can expect sharp questions for board and other competitive exams. Okay students, the first important physical property is atomic radii. So what do you mean by atomic radius actually? It's the distance between or the distance from the nucleus of an atom to the outermost orbital of the electron. See, the atomic radius is this is okay. So it's the nucleus and it's the distance between the nucleus of an atom to the outermost orbital of the electron. Okay. So this is said to be atomic radii. So and now we are going to see how this atomic radii is varying along a period. Okay. See first before that, see I have written what are the different types of elements present in the group 15. Nitrogen. Let me write and show you. Nitrogen, phosphorus, arsenic, antimony and bismuth. Is it not? So these are the different types of elements that are present. See here nitrogen, phosphorus, arsenic, antimony, bismuth. Okay. So these are the different elements present in group 15. Okay. So before discussing the atomic radii, how it is varying, first you should know the atomic radius. Okay, so let me write down the atomic radii now. These are the different atomic radii of these different elements. Okay, so now I am going to explain how this is varying. See, check here the nitrogen, it is 70. See, it is gradually increasing. Is it not? See, the atomic radii increases down the group. Why it is increasing down the group? Why it is increasing down the group? Because the atomic size increases, okay, due to the addition of an electron shell and also due to the poor shielding effect of d and f electrons for each succeeding elements. Okay, see here, see from nitrogen to bismuth, see the atomic number is going on increasing. When atomic number is going on increasing, extra shells will be added. The electrons will be loaded on the extra shells. See here, this is nitrogen and this is phosphorus. Here we are having two shells. Okay, yes, P. See here, see again, you are having 1, 2, 3. So extra shells are there. Okay, what's the atomic number of phosphorus? It is 15. Okay, so again for arsenic, see here, it's going on increasing. Is it not? It's increasing. Again, more shells are there. So automatically the distance between the nucleus and the outermost electron will be increasing. See here, this is for antimony. Here also the number of shells are increasing. So the atomic size is increasing. Again for bismuth, the same thing. Its atomic number is increasing. Is it not? So automatically, see its atomic number is 83. So it's increasing. So the number of shells are also increasing. So that's the reason why the atomic radii is increasing from nitrogen to bismuth. Understood, students? Now let us see the next important property, that is ionic radii. What is the ionic radius? Actually, ionic radius is the distance from the nucleus of an ion and the electron cloud. Just the same as that of the atomic radius, but there it will be an atom, but here it will be in the form of an ion. Okay, so the ionic radius is the distance from the nucleus of an ion and the electron cloud. That is from the nucleus and the electron cloud. But actually here the ionic radii increases down the group from nitrogen to arsenic. Okay, see here, let me write. See here, see students, here from nitrogen to arsenic it is increasing. Is it not? Ionic radius is increasing. Whereas from antimony, see antimony it is decreasing again. For bismuth it is increasing a little. Okay. So but when you are comparing with these three elements, these two values are low. Is it not? So see here these three are increasing, whereas here it's low. Now I'm going to explain why this happens. Okay. See here. Here the nitrogen, phosphorus and arsenic, these three forms negative ions, okay? Negative ions, that is M3 minus ions, okay? These forms M3 minus ions, whereas these two forms M3 plus ions, okay? You should understand why this happens. Why? See, when ionic radii of negative ions are larger, while that of the positive ions is smaller, okay? The ionic radii is smaller. The reason why? Because these M3 ions are formed due to the addition of 3 new electrons in the valence shell. Okay, this is formed, how this M3 minus ions are formed? These are formed due to the addition of 3 electrons. Okay, addition of 3 electrons. Whereas here it is formed due to the removal of 3 electrons. Okay, removal of 3 electrons. Only if 3 electrons are removed, we will get this M3 plus ions. See, when 3 electrons are added, see, in the case of when we are adding 3 electrons, this addition of 3 electrons will be taking place in the valence shell, that is in the outermost shell, that is in the outermost shell, okay? So, in the outermost shell. So, when 3 electrons are added, but the nuclear charge will be remaining the same, okay? See here, if 7 electrons are there and 7 protons are there, will be there. But if 3 more electrons are added here, here will be having only 7 protons, but electrons will be increasing. If number of electrons are increasing and the protons remains the same, and that is the nuclear charge remains the same, automatically the pull of this nucleus on this electron will be decreasing. So automatically what happens, the distance between the nucleus and the outermost electron will be increasing. Okay, it will be large since it cannot pull toward itself. The same thing happens here also. More number of electrons will be getting added up to the valence shell, but the nuclear charge remains the same. So automatically it cannot pull the valence electrons towards itself. So the distance between the nucleus and the outermost electrons will be higher. So that's why the ionic radii is increasing in these three. But in the case of antimony and bismuth, there won't be addition of electrons, there will be a removal of electrons. Okay, so M3 plus are formed due to loss of electrons in the valence shell and the nuclear charge remains the same. Okay, so a nuclear charge will be remaining the same. Okay, so if 3 electrons are removed from here, from the antimony, so but the nuclear charge will be remaining the same, so it can effectively pull the outermost orbit towards itself. Okay, it can effectively pull the electrons that are present in the valence shell, so automatically it shrinks. Okay, this shrinks, this ion shrinks, so automatically what happens, the ionic radii decreases. Here also the same thing happens. This is the reason why the arsenic and antimony and bismuth are having lesser ionic radii, okay, when compared to nitrogen, phosphorus and arsenic. Understood, students? So the next important property is ionization energy. What is ionization energy? Ionization energy is the amount of energy required to remove an electron from an isolated gaseous atom. So actually it is the amount of energy required to remove an electron. Okay. See here, actually this ionization energy is inversely proportional. It is inversely proportional to the size of the atom. Okay. It is inversely proportional to the size of the atom. We all know that the size of the atom is going on increasing from top to bottom. From top to bottom, the size is increasing because of the presence of additional shells. Is it not? Since the atomic size is increasing from top to bottom, obviously ionization energy will be decreasing. Why so selected? Write the ionization energy so that you can come. It's not necessary to learn all these values. Just you want to understand. That's why I'm writing. Okay. So these are all the values of ionization energy of these different elements. Okay. So now we can see there is a gradual decrease in the ionization energy. Why it happens so? As I told you earlier, as the atomic size increases, see the distance between the nucleus and the outermost electron will be increasing. Is it not? See here. So as the size increases, the distance between the nucleus and the outermost electron increases. Is it not? So automatically the pull of this nucleus on this outermost electron will be decreasing. Am I right? So the pull of this nucleus on this outermost electron will be decreasing. So it is very easy for us to remove the outermost electrons. As the pull of this nucleus on this outermost electron is decreasing, it is very easy for us to remove the outermost electron. So it only less amount of energy is to be supplied to remove this outermost electron. So what happens to the ionization energy? What is ionization energy? It is the energy required to remove the outermost electron. Is it not? So since we are supplying less energy, automatically ionization energy decreases. Okay. So as we move from top to bottom, the atomic size increases. So automatically the pull of this nucleus on the outermost electron will be decreasing, and because of this, the ionization energy also decreases. Understood, students? But see, when you are moving from left to right, that is, this is group 14, this is group 15, and this is group 16. So when you move from left to right, the scenario is different, because for group 14, the outermost electronic configuration is ns2 np2. This is for group 14. Okay. For group 15, it is ns2 np3. Okay. So this is for group 15. For a group 16, it is that is an outermost electronic configuration ns2 np4. Okay, this is for group 16. See now check group 15. It is half filled. See this p orbital, it is half filled. Actually, fully filled means 6, but it is half filled. Obviously, half filled will be very stable. Is it not? Half filled will be automatically stable. Since it is stable, we have to supply more energy because it is not that much easy to remove the electrons from the outermost orbital. So we have to spend much energy. So when compared to here, understood? So that's why this one group 15. That's why this group 15 is having a lesser tendency to lose their valence electrons. Okay. Just like ionization energy, electronegativity is also inversely proportional to the size. Okay, so the electronegativity is inversely proportional to the size of the atom. Okay, just like that of ionization energy. So what is the electronegativity? Actually, it is the tendency of an atom to attract a shared pair of electrons towards itself. Okay, it is the tendency of an atom to attract a shared pair of electrons towards itself. Actually, what happens is electronegativity decreases down the group due to an increase in atomic size. See here, when you move from nitrogen to bismuth, when you are moving from nitrogen to bismuth, see the atomic size increases. Okay, so when the atomic size is increasing, automatically the pull of this nucleus on the outermost electron will be going on decreasing when you move from nitrogen to bismuth because the size is increasing. So automatically the attraction of this nucleus charge on this outermost electron will be decreasing. Okay. So what happens? That is here the attraction will be more because the nucleus is near. Is it not? Here it is little far. It is again more far. Okay. So the attraction will be going on decreasing. When the attraction is decreasing, automatically the attraction of shared pair of electrons towards the nucleus will be decreasing. So automatically what is electronegativity? It is the tendency of an atom to attract a shared pair of electrons. Since the attraction, the pulling capacity is decreasing, it attracts less pair of electrons. Okay. So automatically electronegativity decreases when you move from top to bottom. Understood, students? The next important property is metallic character. What happens to metallic character? What is a metallic character? Actually, so it is the tendency of an element to lose electrons and form positive ions or cations. See, when you are moving from nitrogen to bismuth, that is from you are moving down the group. Okay, when you are moving down the group, the metallic character increases. Okay, the reason why, because down the group the atomic size increases. Okay, so automatically ionization energy decreases. What do you mean ionization energy decrease? What do you mean ionization energy? It's the energy required to remove the outermost electrons. Okay, so when you are moving down the group, the atomic size is increasing. So ionization energy decreases, and so automatically what happens? The valence electrons can be easily removed. When the valence electrons are easily removed, the electropositive character increases and obviously the metallic character increases. So you see, when electrons are removed, the positive character will be increasing. Is it not? I told you earlier, these two can easily form M3 plus ions, whereas these three can form M3 minus. So moving from top to bottom, the metallic character, okay, the metallic character increases. Okay, that is the electropositive character increases. That means it can easily remove or it can easily give away the outermost electrons. Understood, students? See, next important property is density. So what is density? It is the ratio between mass by volume. Is it not? It's a ratio between mass by volume. Actually, what happens here is the density increases as we move down the group. So I have written all the elements now: nitrogen, phosphorus, arsenic, antimony, and bismuth, and I have given the mass values. What is it for nitrogen? It's going on increasing. Okay, so the percentage of increase is also increasing here. But look at the volume. Volume is also increasing. See if mass and but the volume is not increasing much. Okay, so actually here if you are watching here, the change in mass is at high rate. Okay, the change in mass is at high rate when we are moving from top to bottom. But when you are moving from top to bottom here, the change in volume is at a low rate. Okay, so the change in volume is at low rate. So let us see the ratio between these two. What could be the values of density now? So when you are finding out the ratio of mass by volume for nitrogen, it is 0.1. For phosphorus, it is 0.125. Okay. For this one, it is 0.27. For this one, it is 0.36. For here, it is 0.56. See, now we check the values of density. It is going on increasing as we move down the group. Okay. Since the change in mass, it is at high rate and it is at low rate, we could see a gradation, right? There is a small increase in all the values of density as we move down the group. Understood, students? So next important property is the melting point. See here, the amount of energy. What is melting point? It's the amount of energy required to break a bond. Okay. See here, in the case of group 15, the melting point increases from nitrogen to arsenic. From nitrogen to arsenic, but it decreases from arsenic to bismuth. Okay. See here, it is increasing from nitrogen to arsenic, but it is decreasing from arsenic to from this one to bismuth. So now we are going to see the reason why it happens so. Okay, actually the melting point actually depends upon three important criteria. One is crystal packing. Okay, see if that crystal is tightly packed, then automatically the melting point will be high. But if the crystal packing is very loosely, if it is loosely held or if it is loosely packed, then the melting point will be low. Okay. And the next important criteria is the force of attraction involved. Okay. Sometimes it may be a covalent bond or it may be an ionic bond or it might may be a weak van der Waals force. And the next, the bonding nature. So these three criteria are very much influencing the melting point of the particular element. Okay. Now let us see for nitrogen what is so. So actually this nitrogen is non-polar molecule and it has weak van der Waals force, so the melting point is very low. Since it is having this nitrogen is non-polar and it is having weak van der Waals force, it is very easy for us to break the bond, so automatically the melting point is low, that is 63. Okay. Now this phosphorus actually it is a solid. So it has covalent bond and that's why its melting point is little high when compared to nitrogen. Okay, it is a little hard to break the bond. But when you are taking into account arsenic, this arsenic, the atoms are just arranged in, what to say, the different arrays just like that of silicon. Okay, so it is, it's very hard to break the bond, so its melting point is little high, very higher when compared to these two elements. Okay, but when you are taking into account antimony and bismuth, see this antimony, what happens? The antimony and bismuth, due to the tendency to form three covalent bonds. See, these two will be forming three covalent bonds. Okay, they form three covalent bonds. Okay, and also due to inert pair effect exhibited. Okay, inert pair effect exhibited by these two, arsenic and bismuth. So what happens? This results in a weakening of attraction among the atoms. Okay, so automatically what happens? The melting point decreases. Okay, melting point decreases. That's the reason why, because it forms three covalent bonds instead of forming five. Okay, here all it's five, but here inert pair effects plays a vital role, and automatically it weakens the bond. This inert pair effect weakens the bond and leads to the lowering of the melting point of these two elements. Okay, this antimony and this one. Understood, students? Boiling point. Actually, boiling point increases from nitrogen to antimony, but decreases in bismuth. See, from here to here, from nitrogen to antimony, it is increasing, is it not? But again, from antimony to bismuth, see, in bismuth it is decreasing. Okay, here it is increasing, but here it is decreasing. Understood? So the reason why, because why it is increasing from top to bottom there from antimony, it's because of the atomic size. Okay, atomic size is increasing. Okay, but what happens? See, in the case of antimony, it has five shells. This antimony, it has five shells. Okay, it has five shells, five electron shell. Whereas here, this bismuth, it has a six electron shell. Okay, so automatically what happens, since it is having five shells, the attraction will be more. The attraction will be more. Okay, so its attraction will be more. That is, the outermost electrons will be attracted by the nucleus very effectively. So attraction will be more. So we have to spend a lot of energy. So automatically boiling point will be high. Whereas here it is 6 electron shell. So since it is 6 electron shell, the nuclear pool will be less. So it is easy to remove the electrons. So automatically we have to spend lesser energy. So boiling point decreases in the case of bismuth. Understood, students? This is the reason why the boiling point is lower in the case of bismuth when compared to antimony. Well, fine students, you might have understood what I have taught today. Let me meet you with another important topic in my next video. Until then, it's Dr. Anita Raj, your chemistry mentor, signing off from you. Thanks for watching.